Hi guys, this is the chapter 6 practice test. Let's go ahead and get started here. All right. So solve. When you're solving any polynomial, you're looking for where it crosses the x-axis, otherwise known as what you're trying to find. Oh no, sorry, you're trying to find the zeros, right? So we're trying to find the zeros here when it's asking to solve. So the first thing I'm going to do, these look pretty factorable, but don't forget, if you have any quadratic, you can always complete the squared to solve or use the quadratic formula. Remind me to put that on the board for you guys. But let's go ahead and set these equal to 0. So if I look at A, 3x squared, I'm going to put everything on the same side, plus 9x minus 12 equals 0. And then I have an A here, so I can do that trick where I multiply the 3 times the 12 and factor by grouping, but I notice that everything is divisible by 3, so I'm just going to get rid of that 3. Remember, you can do anything to an equation or a function as long as you do it to each part. So I have to take every number, including the 0, and divide it by 3. So now I have just x squared plus 3x minus 4 equals 0. Okay, now I'm just looking, it's really easy to factor. Now I'm looking for two numbers that add up to be 3 and multiply together to be negative 4. And I believe that that is positive 4 and negative 1. So I have x plus 4 times x minus 1 equals 0. So x plus 4, what number plus 4 equals 0? So my first x is going to be negative 4, and my second x is going to be positive 1. So I can I already know, I can kind of sketch out what this looks like anyway, right? It's a positive quadratic. X crosses, we have a negative 4 here, a positive 1 here. My line of symmetry is going to be like negative 1.5. What's right in the middle between these two numbers? Negative 4 plus 1 is negative 3 divided by 2 is negative 1.5. So just so you guys know what this looks like, right? That's going to be my minimum point. If you wanted to actually find the y value, you could put this negative 1.5 back in for x, and you could solve for y right here, but I know that's what it's going to kind of look like. And there is a word problem where some of this that I just did will make it a lot easier for you anyway. Okay, I'm going to delete this stuff so we can do the second one. The second one's a cubic function because my highest degree is x third for b. So I know I could have possibly 3, I'll just use the eraser. I could have possibly 3 zeros, in which I've done this already, so I know I have 3 zeros actually. So let's get everything on the same side. X cubed, oops. And then I'm going to go ahead and subtract 8x squared. It's always a good idea to have your degrees in order, so I start with 3, then 2, then the positive 7x is already there, equals 0. Okay, and here I don't have to do anything crazy with the cubic because everything has an x. So the first thing I'm going to do is just factor out an x, and then in parentheses all I have is a quadratic, which I think is a pretty easy one to factor. See, I just took out 1x, I factored out 1x from everything, so now it's only x squared, it's only x, and then the 7 doesn't have anything. I don't know what I just did there. Equals 0. So now since I'm multiplying, I can just factor out what's in the middle. So in the middle, I'm looking for two numbers for that quadratic that add up to be negative 8 and multiply together to be positive 7. So that's going to be negative, x minus 7 and x minus 1. Negative 7 and negative 1 is negative 8. Negative 7 times negative 1 gives me positive 7. Since I have one random x, I don't know why it's writing. Since I have that x on the outside, I know one of my zeros is going to actually be 0. Okay, so x1 is 0. x2 is going to be positive 7 because positive 7 minus 7 is 0. Okay, and x3 is going to be positive 1 because positive 1 minus 1 is x sub 3, also 0. Okay, so now I know what this looks like. It's a cubic function that's going to cross at 0, positive 1, and positive 7 out here, right? And it's a positive, so I know it's going to go up at the end, and it's going to start from below. So I imagine, oops, sorry guys, it's going to look something like this. This should be not have that little dip there. Okay? All right, tell whether each equation is written in general form, vertex form, or factored form. Write each equation in the other two forms. We'll just do one of them where we rewrite it. If you need the extra practice, you should definitely do all of them. But this for sure, A is factored form, right? B is vertex form. And the vertex is positive 1, because it's the opposite, comma positive 2. The y value stays the same, but the x value is the opposite there. And the last one is in general form. Okay. All right, so we can change A to be general form by just multiplying it out. So let me see. Oops. That's the problem. Let me turn my pen back on, you guys. So if we just multiply, sorry. Let's see. 2 times x, I'm going to first distribute that 2 here. 2 times x is 2x minus 6. Okay, see what I did right there? Then I'm going to multiply that by x minus 2. Here. And we get 2x squared minus 6x minus 4x plus 12. And when we combine it, we get 2x squared minus 10x. I combine that negative 6 and that negative 4 plus 12. Okay, and now I have general form, right? So I just simplified it, general form. Then, if I wanted to change this to vertex form, I can take my general form and complete the square. So the first thing I need to do to complete the square is to have a 1 where the a should be, and instead I have a 2. So if I just take my equation, set it equal to 0, and then divide everything by 2, I should have, I should be able to do this a lot nicer, okay? So 2 divided by 2 is just x squared minus 5x plus 6. And I still have to divide that 0 by 2, but when I divide 0 by 2, I still get 0. So it's just equal to 0. Now I take, I guess I didn't need to do that, did I? I thought I could make this go down, but let's just do this. Half of this number and square it. Oh, first I want to move this positive 6x to the other side, right? If you guys were screaming at me, that's my fault. So I have x squared minus 5x equals negative 6. Now I take half of negative 5 and square it and add it onto it. So I have x squared minus 5x
Half of negative 5, I'm going to do this up here. Half of negative 5 is negative 2.5, and if I square it, that is positive 6.25. And I'm going to add 6.25 equals negative 6. But remember, what I do to one side, I have to do to the other. So if I added 6.25 over here, I have to add 6.25 on the other side. And then I can turn this into a perfect square. So I'm going to erase some of this work over here so that I can continue. So I now have x squared minus 5x plus 6.25 equals just positive 0.25. Then I'm going to change this to be a perfect square. So I have x minus, what was half of negative 5? 2.5 squared. Okay? X minus 2.5 times x minus 2.5 is this. So it'll give us this back. I have not changed anything. I've just changed the way it looked. It just looks different. Equals 0.25. Now I need to bring that back over to the other side. So I have x minus 2.5 squared minus 0.25 equals 0, or I can change that to y now. This is in vertex form. My vertex is positive 2.5, comma, negative 0.25. And you can check that on the calculator, okay? What's next? Oh, we did this in class. So I won't do this one because we did in class. So if you need more help with that, come see me. But I will do this one down here. I'm going to create an equation for it, and I'm going to do it in factored form since I know my zeros. This is a quartic. There could be 4 zeros. Okay, what zeros do I see? I see 1, 2, 3, because this only touches down here. There's not 4, but I know my degree has to be to the 4th power because of the shape and it's even. So I'm going to go ahead and find my zeros. I have an A, I don't know what it is yet, but I know my first 0 is negative 5, so I need to make that x plus 5. Then I have negative 2, so another 0 is x plus 2, because if I put a negative 2 there, it becomes 0. And then my last 0, where it just touches, is positive 2, so I say x minus 2, but since it just touches, I'm going to square that, okay? Then it gives me another, so I need to find a still, right? I can't find a unless they're all numbers besides a. So I need to put these numbers back in here. So I have 20 equals a times, and my x is 0. So 0 plus 5 is just 5. 0 plus 2 is just 2. And 0 minus 2 is negative 2 squared is positive 4. Okay, so 5 times 2 times 4 is 40. So 20 equals 40 times a. So a is just equal to 1/2 because 1/2 times 40 is 20. So my equation is y equals 1/2 times x plus 5, x plus 2, x minus 2 squared. And you can simplify this. You can multiply them all together if you like, or you could just leave it like that. Consider the polynomial function. List all possible rational zeros of this function. We didn't do this in class, so I really want to go over it with you before we take the test. If you guys could remind me tomorrow, I will do this with you. This makes our homework faster also. Eli stands on the balcony of a tall building and throws, I'm just going to draw this. Here's the building. And throws a tennis ball straight up at a speed of 18 meters per second. He releases the tennis ball at a height of 50 meters from the ground. So this is 50 meters. In parts A through C, round your answers to the nearest 100. So let's just do a quick sketch of what this looks like. He throws it here. It's going to go up a little higher. And then it's going to come down to the ground. And we're dealing with meters per second. So there's one thing we need to know. And if it doesn't tell you on the test, I'll give you this information. What you need to know is the equation when you're dealing with gravity for a quadratic. And gravity in meters per second is going to be negative 9.8 meters per second squared. But the negative comes in because in our equation we have a negative quadratic because it goes up and then down again. So both ends point down. In our equation, this becomes the first term. So we have f of x, or f of t really, because it's time, is equal to negative 9.8. Sorry, guys. Negative 9.8 x squared. And then next we put our speed. So we have plus 18x. And then last we put our y-intercept, which is plus 50. Okay? So once you have this, you can enter it into your equation, or you could turn this, these were some of the problems we did on those practice problems, I think, word problems. You could turn it into vertex form to figure out all this stuff. Or I went ahead and put it into the calculator. There, if you look at the calculator up at the top, that's the equation I put in. And now I can answer, when does the tennis ball hit the ground? Well, it's over here at this 0, so I can use the calculator graph function. So if I just do second calc, and I want to find the 0, so I arrow down to 2. Left bound, yes, and then I go on the other side of the 0 to where y is negative. Enter, and then guess. So approximately 3, my x is 3.36 approximately for A, approximately 3.66 seconds. Okay, and when does the tennis ball pass the point from which it is released? Actually, they probably did it as the height, no, of a tall building, the ground of parts A through C. When does the tennis ball pass the point from which it's released? That's just going to be at 0, where x is 0 right here. Okay, my y-intercept. That's where the ball's released. What is the maximum height reached by the ball? And when does it reach this height? So that's just finding, sorry you guys, the vertex. If we go back to the calculator and we do second calc, we'd like to find the maximum, number 4. Enter on this side, and we go to the right-hand side. Enter, enter. So its maximum height is approximately 58.26. 27, actually, if it wants us to round. 27, what are we dealing with? Meters, okay? And that is at 0.92 seconds. So my x is the seconds, and my y is the meters. Sorry, guys, I'm still getting over this cold. All right, number 6. Oh, this is kind of like what we were doing before. Write an equation in general form for a 4th degree polynomial with real coefficients at zeros I and, zeros I, and it looks like we're missing part of this question. Let's just make up a question. Write an equation in general form for a 4th degree polynomial with real coefficients, zeros. It just needs our zeros and our y-intercept. So if our zeros are -3, 4, and I want 4 because it's a 4th degree polynomial, right? 5 and -2. Real coefficients just means real numbers a, b, and c, and our y-intercept as 27. So we should just be able to say, if those are my zeros, I have x plus 3 times x minus 4 times x minus 5 times x plus 21. And I know nobody was working on this too hard because there wasn't any questions about this one that didn't have all of the questions in it. So in order to get the find the y-intercept, first let's multiply all of this together. So this is going to be, I'm just going to FOIL in my head, x squared. I'm going to multiply these two together, and then these two together, and then multiply the answer together. So x squared minus x minus 12 times, and this is going to be x squared minus, plus, what's 21 minus 5? 17? 16? 16x minus 5x. Is that, nope, just minus 5? Oh no, 5 times 21. Sorry, you guys, I'm doing this in my head. 105 minus 105. Okay, and then I'm going to put those in a box. All right. I'm making this way harder than it is. If you want to keep going through this and finding out what you need to add to make the y-intercept 27, but actually this can just be written as, don't kill me for having watched all of that already. I hope you got something out of it. We can do 3x to the 4th minus 2x cubed. Those are all real numbers. Plus, oh, nope, this has got to, yep, these are all real numbers. Minus 2x cubed plus 3x squared minus 4x. And then here's my y-intercept, plus 27. Ha! That was way easier than I was making it. Please don't hate me. You guys can do this. You can scratch this and show the behavior. It should look something, it's a positive quartic. So it should look something, and it goes through 0, right? It should look something like maybe like this. It's positive, so both ends are positive. I know it goes through 0, so it's got to go through here at some point. But just put it into your y equals and see what happens. 8. Which ordered pair is a solution to the systems of equations? Just put this into the calculator and let's find out. The answer is going to be where they intersect, right? So we have x minus 5. Oh, I could do this by hand. Let's do it both ways. Then, in case it asks you to show your work, negative x squared plus 1. And let's just do a zoom 6. Okay, yeah. So on your calculator, you can find out what these points are here. Okay, but also, I think what this really wanted you to do is say, where are these two equations equal And we can just solve this for x. Let's get all of our x's on one side. Let's make our x squared positive. So we have x squared minus 1 plus x, minus 5. Okay, so I just moved these to this side, and then I'm going to set it equal to 0. And you can solve this quadratic any way you want. Quadratic formula, completing the square. I'm going to try to factor it, because this should be, if I put it in order, x squared plus x minus 6. So two numbers that multiply together to be negative 6 but add up to be positive 1. That should be x. So one has to be positive, one has to be negative, and they need to be 1 apart. X minus 2 times x plus 3. Okay, so our answers, they should cross at x equals positive 2 and on one of them, and x equals negative 3 on the other. But remember, it wants an ordered pair. So let's just go back up here. If I put positive 2 in here, okay, then my output is 2 minus 5 is negative 3. So one answer is 2 comma negative 3. And the other answer, if I put negative 3 in for x, my output would be negative 3 minus 5, negative 8. And you should be able to check yourself on the calculator for that one. This one looks like when our rational zeros came up again. I'll go ahead and go over this one, and then we can go back over the first one in class. There's something that we learn called the rational zero theorem. Okay, and what the rational zero theorem says is, what values can we make x that will make this function equal 0? And you can make a guess about that by finding two things. You put them in order, you find the highest degree first, you put that first, and then you put the constant term last. Then you find all the factors of each. P is going to be the factors of the constant. So all the factors of 24, okay? And those could be, what numbers can we multiply together be 24? We can do 1, 24, 2 and 12, 3 and 8, 4 and 6. And I think that's it. And then it starts going backwards. So here's all the factors of 24. Then we make Q equal to all the factors of the leading coefficient, which is 2, because it's 2 in front of x cubed. 3 is the largest degree. So the factors of 2, that's a lot easier. Factors of leading coefficient. And they're just 1 and 2, right? So then we make, I'm losing my words. We make fractions of each one, so we make all the possible fractions we can with P on the numerator and Q on the denominator. So our first denominator is 1. Well, if we take all of these numbers and put a 1 on the denominator, all we do is we get all of those numbers back. So each of the factors here are possible rational zeros. Okay, then we do it again, but instead of having 1 on the denominator, we have 2. So if I did that, if I took each one of those and put it over 2, my first one would be 1 over 2, which is just 1/2. My second would be 24 over 2, which is 12. 2 over 2 is 1. 12 over 2 is 6. 3 over 2 is 1.5, or I'll just put 3 over 2. 8 over 2 is 4. 4 over 2 is 2. And 6 over 2 is 3. Okay, so all of these plus all of these are all of our possible rational zeros. Now, in order to figure out which ones really are, you would put each of these numbers back in for x, and the numbers that gave you 0 back, would be your answers. But it just asks for all the possible rational zeros, not all of the zeros, so we're good. Oh my goodness, you guys, how many questions did I give you? Okay, so we just multiplied these two together. 7 minus 5i times negative 2 plus 4i. And I'll just make our little box. So this is negative 14. This is positive 10i. This is positive 28i. And this is negative 20i squared. But remember, I squared is always equal to negative 1. So negative 1 times negative 20 is just this whole box here is just going to be positive 20. So if we rewrite this, 10i and 28i is going to give us 38i. And negative 14 and positive 20 is just going to give us positive 6. Okay? So simplified, that's going to be our answer. And this I is imaginary, so we can't change it. It's 38 times the square root of negative 1. And why don't you, oh, this one doesn't want us to multiply, it just wants us to simplify, so we just do the same thing. 12 minus, you just treat it like a variable unless we ever get I squared. I'm going to distribute this negative. Negative 4 minus 9i. Combine my like terms. So 12 minus 4 is 8 minus 14i. Okay. Oh, finally, the last question. So the first thing I think your paper asks you to do is write a table for each of these. Okay, so if we do x and, oops, that was terrible. X and f of x. And we do one that is x and g of x. You see where I'm going with this? Let's go back to blue. If x is negative 4 on the blue line, my f of x is positive 1. If x is negative 3, I have, oh, that was 0. Sorry, you guys. 0. Negative 3 is positive 1. Negative 2 is 0 again. Negative 1 is negative 1. 0 is 0. You may have to keep going. Let's do the red one. In this one, it looks like it starts, if we do negative 3, we have negative 1. Negative 2 is positive 2. Negative 1 is positive 3. Zero is 2. 1 is negative 1. Okay, you see where I'm going with this. There's your tables. So is f of 2 greater than g of 2? Oh, I didn't find f of 2. F of 2 is 0. The blue line at 2 is 0. The red line at 2, well, I don't know what it is, but it's very much smaller than 0, right? So f of 2 is very much greater than, the blue line is very much greater than the red line at 2. The y-coordinate of the y-intercept of f of x, so that's 0, that's that blue line at the y-intercept, is blank, then the coordinate is smaller than. So the blue line is smaller than the red line at the y-axis, right? Smaller than. The minimum value of f of x on the interval from 0 to 3. So from 0 to 3, the minimum value for the blue line is, oh, right here at negative 1, right? It's my minimum value just from 0 to 3. And the minimum value of g of x on that same one, the minimum value of g of x is going to be way down here. So g of x is going to be smaller, okay? the average rate of change of f of x from 0 to 2 and the average rate of change of g of x from 0 to 2. Okay, so what was our two values here? Let's change that from 0 to 2 to 0 to 1 because we don't know what 2 is on the red line exactly. But the average rate of change is going to be to find the slope. So we're trying to find the slope of the red line, and we have 2 points. We have x is 0, and that means y is 2. And we have, if we make this instead of 2, if we make it 1, then we have x is 1 and y is -1. So find the slope there. That's the average rate of change. And the slope for the blue line, which is f of x, if we use those same points for x, 0, and 1, 0 is 0, and 1 is 1. So actually, the average rate of change here is just 1. And the average rate of change for the red line is x is going up by 1, y is -3. So which one's bigger? The slope? Well, the average rate of change is technically smaller for the red line at -3, right? But it's a steeper slope, so I'm actually not sure what they wanted with that. I think the question on the test may be a little less ambiguous, but as long as you know how to find the slope, we'll deal with the rest later. So I hope you have fun studying for the test, and I will see you guys tomorrow.